So which other element in Q that is not being represented?
Teacher, I beg you ring the bell. Teach your children, teach them how to.
So welcome to my YouTube video. In this lesson, my focus is on the Venn diagram. So I believe this is my third lesson in relation to sets. Now, I want to look specifically at the Venn diagram. As the information says, Venn diagrams are pictorial representations of sets. So it's like a picture of the set. Now, in so doing, there are some terms that we have already familiarized you with in the two previous videos. Let us say that we have two sets. Set A, the elements are 1, 2, 3, 4, 5, 6, 7, and 8. And another set may be, again guys, set connotated by a capital letter. Another set, let us say the elements are 2, 4, 6, 8, 10, 12, 14. Now, these are our two sets, sets A and set B. Now, in a previous lesson, we spoke about intersections within sets, whereas both sets may have common elements. And we also spoke about the union of the set, whereas the elements are being combined within the set. Now, if I was supposed to do the union of A, so let us say A intersect, so that's a symbol, A intersecting B. So what would be the elements in A intersecting B? So here we want to identify what elements are common to A as well as the elements common to set B. So from here we can see they are 2, 4, 6, 8. Are there any other elements common to both sets? 2, 4, 6, and 8. So these are the common elements in both sets. If I was supposed to do the union, A union B. Now we are looking at all elements that are common to both sets. So the elements, and guys remember, we don't repeat an element and the order is not important. 1, 2, 3, 4. There's 5. There's 6. There's 7. There's 8. There's 10. There's 12. And there's 14. So that would have been the union of both sets. Now, this information here can be represented on a diagram by which we refer to as the Venn diagram. In most cases, the Venn diagram are normally being represented by using circles. Circles represent each set. So let me try to get some space here. Now, because there are common elements in both sets, that in itself tells me that the Venn diagram will intersect. So in other words, both circles will overlap. So I can refer to one of the circle as A and this one as B. A Venn diagram is normally being represented too by having a rectangle around it. So in most cases you see Venn diagram, the rectangle around it. And we'll see some person put the symbol. So this symbol here means universe, right? That's what the symbol may connotate on the Venn diagram. Now, what we need to do, so this area that I'm shading in blue represents the intersection. And what goes in the intersection here are basically the elements that are common to both sets. So, in representing what elements are common to both sets would be 2, 4, 6, and 8. These are common elements, hence those elements are represented in the overlapping or the intersection. Note, guys, that there are other elements that are also in set A as well as set B that are not being represented. So what we need to do, the other elements such as 1 will go in set A, 3, 5, and 7. So these are the elements that will be representing in set A. So if we look, 1, 2, 3, 4, 5, 6, 7, right up to 8. 2, 4, 6. There are 8 elements in set A, and I'm pretty sure number of elements in set A, 1, 2, 3, 4, 5, 6, 7, 8. Likewise, there are some elements in set B or members in set B that have not yet been accounted for. Therefore, we are talking about 10, 12, and 14. Hence, these elements goes in set B, 10, 12, and 14. So this would have been a pictorial representation of both sets. Remember now, you can always pause the video and go back and look at this example. Let us try another one. So take a look how it is being represented. I use 2 sets. Let us take another set for argument's sake. Let us take so I'm using set. This time I'm using M. The elements in M are A, B, C, D, E, the letter F. Taking a set, they are represented by N. And in N, the elements are A, C, E, G, H, I, and K. These are the elements. So again, guys, you can pause the video and on your own you can decide what are the intersection, what would be M intersecting N. So what would be M intersecting N? Again, as a refresher, we said that we are looking for common elements that exist between these 2 sets. And the common elements in this case would be, we see A being common. Is there B? No. We see C being common and E being common. There are any other elements? Absolutely not. What about the union? M union N. So again, we are listing all elements. We are combined. We don't repeat an element. That would be A, B, C, D, E, F being separated by commas. There are any other elements. We have A, B, C. So we need to put in G, H, I, and K. So these are the union of both sets. Now we want to put this onto a Venn diagram to give us that pictorial representation. So I'm going to be drawing two circles. Are they joined? Yes, because there's an intersection. So these are my circles representing my Venn diagram, and symbol representing the universe. This is M, and over here I kept N. What about the intersection? Are there common elements? Yes. So the common elements are A, C, and E. This goes into the intersection. Again, I'm going to be look what other elements in A, sorry, not A, what other elements in M that are not yet represented on our diagram. And these would be, if you were being asked, what is the intersection of M intersecting N? Is there a common element between M and N? Do we see any common element? The answer is no. So there is no common element. Therefore, what we can say that M intersecting N is an empty set. And note, guys, I put nothing in this in the brackets, or I could write an empty set as this symbol. Do not make the mistake and put this symbol in the brackets. That would mean that the symbol is not an element. So these are the two symbols that are used to represent an empty set. But what about M union N? This we can find. We are looking at all the elements, which would be A, B, C, D, E, F, and G. So in terms of the union, so what if you were asked number of elements? This is how it's written, guys. Number of elements in M union N. What we need to do is to count the elements. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So there are 7 elements. Now, can we represent this information on a Venn diagram? Is the answer yes? Yes, we can. There's no common element between both sets. So we know then that the sets do not intersect. But one circle can represent, so this will represent M, this will represent N. What are the elements of M? A, B, C, and D. What are the elements here? E, F, and G. In this case, where the elements are not common, we refer to it as a disjoint set. Right? Still representing on a Venn diagram, but this time no common elements. We refer to it as a disjoint set. Now, I've done examples with 2 sets. Let me try one with 3 sets. So I'm going to do one that having 3 sets. Again, guys, you can pause the video and watch at your own pace and your own convenience. let us use, this time I'm using, try to get a different color. So I'm using P. So say P gonna have, I'm using letters again, 2, 4, numbers I'm using 6 and 8. And OPQ, so Q is gonna have the elements 1, 2, 3, 4, 5, and OPQR, and R we're gonna use the elements, use a different color. For R I'll be using 1, 3, 5, 7. Let me not use, I want a common element in all 3. So we have 2. Let me use 1, 2, 3, 4, 5, 6, 7. And I'm gonna put 8 in this one. So guys, look what we have on the chartboard. We have 3 sets in this case. Now, are there common elements to all 3 sets? If we were to write here in terms of intersection, it would be P, where's my green marker? P, that is P intersecting Q intersecting R. So we want to find what are the common elements to all 3 sets. So if we were to identify 2 is here, 2 is here, 4 is here, 4 is here. Now, what about the 2, 4 is there, 2 is here, and 4 is here. Note carefully. And what about the union? P, union Q, union R. Gonna put all elements combined. So this will go from 1, 2, 3, 4, 5, 6, 7, and 8. So that's the union. Now, we want to represent our pictorial representation of what we have on the chartboard. Hence, we'll have 3 circles. So I'll call this one P. We're gonna call this one Q, and my third will be R. Now, first of all, we want to identify that common area that overlap in all 3 sets. So all 3 sets would be, the elements are 2, 4, 2 and 4. So in this case, our 2 will go here and our 4. Let us look carefully. This little area here is representing P intersecting Q. What's the intersect between P and Q? Are there any other elements that are only in P and Q? Do we see any elements that are just in P and Q and not R? No. What about here? This is Q intersecting R. Are there elements that are only in Q and R? Let us look. So 3 is common to Q, 3 is common to R. Any more? 5 is common to Q, 5 is common to R. So therefore, 3 and 5 will go here. Are there any elements that are common to just P and R? That is this intersection here. P and R only? Yes, we see, let me use a different color. We see 6 here is common to P, and the 6 is common to R. We also see 8 is common to P, 8 is common to R. Therefore, P intersecting R, which is this area, would be 6 and 8. So note now, guys, what are we going to be doing now? We're going to be looking carefully what are the elements that are in set P that are not yet being represented. Set P has 2, 4, 6, and 8. Can I see them in set P? Yes, they're all 2, 4, 6, and 8. So set P is okay. What about set Q? Are there any elements in Q that are not yet being represented? We have a 2 here being common. We have 3, we have 4 and 5. So 1 is common to Q and R. Now we realize that 1 is also common to Q and R, guys. So 1 should be here as an element. 1 is common to Q and R. So which other element in Q that is not being represented? So all the elements are being represented. Now let us look at R. Are there any other elements that are not in R that has not yet been represented? The only element there is 7. So bear in mind, as I indicated, it can be a little more complicated when we are dealing with 3 sets. However, all we need to do is take our time and list the various elements. For example, you could have taken your time. I could have gone ahead and just do the elements in terms of, I could have gone and do P intersect just Q and identify what those elements are. So if I ask from the Venn diagram, what is P intersecting Q? There any elements of P intersecting Q? No, that's an empty set. What if I ask, what are the elements in Q intersecting R? Are there elements that are common? So which other element in Q that is not being represented? So all the elements are being represented. Now let us look at R. Are there any other elements that are not in R that has not yet been represented? The only element there is 7. So bear in mind, as I indicated, it can be a little more complicated when we are dealing with 3 sets. However, all we need to do is take our time and list the various elements. For example, you could have taken your time. I could have gone ahead and just do the elements in terms of, I could have gone and do P intersect just Q and identify what those elements are. So if I ask from the Venn diagram, what is P intersecting Q? There any elements of P intersecting Q? No, that's an empty set. What if I ask, what are the elements in Q intersecting R? Are there elements that are common to P and common to Q and R? Yes. The elements are 1, 3, and 5. Hence, they go in this intersection. Could have asked the same question. Again, what is the intersection between P and R? Again, we look for what elements are common to P and R only. And these were 6 and 8. So I could have listed them before, representing them on the set. So when it comes on to working with 3, it might be a little more tedious. However, It's achievable. You just need to take your time. So I've come to the end of this lesson, introductory lesson to Venn diagram. I'll be doing more lessons on Venn diagram itself, as it might get a little more complex. So this is the end of this lesson, guys. I am out.